I mean, level design is pretty easy. All you gotta do is this, fill in over here, move a few of these tiles, and we're done. Let's just zoom out a bit and take a look at the map. Oh As a programmer, when I'm tasked to create levels, only two words come to mind: procedural generation. Not to be confused with random generation, that's just placing objects randomly with no concept of order. If Minecraft had random generation, it would look like this. Procedural generation is a subset of random generation where object placement is randomized but must satisfy a list of conditions. Apply that to Minecraft and it looks a lot better. Now, I have a challenge. If you look at existing procedural generators, you can put them in different kinds of categories: voxels, room placement, height maps, and mesh manipulation. But among these, very few games have pulled off true 2D generation. Let's take Dead Cells, Spelunky, and Binding of Isaac for example. Their maps use room placement for their procedural generation algorithms. They create mazes of rooms that all connect to each other. Then they randomly pick a suitable predetermined room design to fill that room. Every room you see has been handcrafted to be balanced, fair, and enjoyable. So how can we procedurally create these room designs? The first algorithm I came across was Cellular Automata. The concept of this algorithm is to first start with complete chaos, then smooth it out into recognized structure. Let me show you what this looks like. Here in the Unity editor, I have set it to create a 100 by 100 grid. This generates a solid block of square. The first step is we need to create the chaos. And what better way is there than to create a noise grid? Now a noise grid is created by iterating through every single tile and making it filled or empty depending on a pre-arranged probability. Now the Cellular Automata algorithm will go from left to right and rearrange the tiles as it goes. Let's run it. Now the more times we run this algorithm, the smoother it gets. It looks like magic, but this algorithm is actually quite simple. It iterates through every single tile and runs the same check for all of them. It first counts all of its surrounding neighbours that are filled. In this case, there are 5 filled neighbours. If the number of filled neighbours is greater than 4, then it fills it in. If it is less than 4, it makes it empty. If most of its neighbours are filled, it becomes filled. If most of its neighbours are empty, it becomes empty. Every single tile is trying to become like its neighbours, causing the pattern to appear smoothed out. Now this is a great solution, but for Uproot, our map size is small, so we want to limit the number of dead ends so the player doesn't get trapped. We need lots of small tiles to jump on. We don't want things to become smoother. So now let's get our hands dirty and create our own procedural generation algorithm. Okay, let's pull everything back. What are our goals for this algorithm? Hyacinth needs to fit in every space. She needs space to rotate. The map should be closed and there should be no unreachable areas. Let's address the first one to begin with. Now Hyacinth is a 2x1 character, which means every point of the grid should accommodate the size requirement. So here's what we'll do. We'll loop through all the tiles and stop when we find an empty tile. Now we'll check the left and right tiles to determine if there is a 1x1 horizontal gap. If so, we'll randomly pick one of the left or right tiles and make it empty. This process is also done vertically too. Now at any point there should be no 1x1 gaps. Let's apply this logic and test it out. You will notice that it has to redo the algorithm a few times, because the spots it removes could itself become a 1x1 gap. So the algorithm keeps looping until it detects no changes are made. So that's our first one off the list. Now how do we even begin to approach making every single tile rotatable? Let's start with a tile and say Hyacinth is facing upwards. Now let's say she wants to rotate to the right to end up in this position. What do we need to do to make this happen? Well, let's check the tile directly to the right and check that it's empty so we know we can actually rotate there. Then if it is empty, we remove a 2x2 square of tiles in that direction to ensure Hyacinth can rotate there without bumping into anything. Then we do this logic for every single rotating case around the block. For example, let's propose the pattern is an L shape and we're investigating the middle tile. The tile to the left and beneath it are empty, so we should remove these 4 tiles so we can rotate in the bottom left of the tile. Let's go back to Unity and apply this logic and see how it looks. Now you will notice there are no points where a 2x1 player couldn't fit and the player can now rotate around every single block. Alright, he's still with us? That was a mouthful. Good news is the next one is fairly simple. The next one simply requires that the tile grid is closed and that you can't escape it. We'll simply accomplish this by adding a perimeter around the outmost tiles in the map. Now we come to a situation that many procedural generation algorithms face. It is a daunting task with many solutions. How do you resolve unreachable areas? You will notice that there are a few spots that are closed off from the whole level. A common solution is to try and join this up to the rest of the map. But I'll offer a far easier solution. Just fill them in. Let's put this logic in and see it in action. Now these are the very last steps. Before showing what it looks like all together, we need to add two more things, boundaries and props. Let's say the player is in the top right of the map. All they see is empty space beyond the map, so let's create a border around the map. For props, these are the ones I have right now, and we need to somehow put them in the level. I have 1x1 props, 1x3 props, and 2x2 props. So the first thing is to loop through all the silver tiles and find all the ones which have an empty tile above them. These fit the 1x1 props. Then out of these, check all that have 2 more empty tiles above them. These will fit the 1x3 props. Then check all the ones which could fit a 2x2 square in. Now let's loop through all these lists and place the prop there if it is successful in spawning. Alright, you made it to the end of the journey. Let's put all these algorithms together and watch it blossom. Now I know what you're thinking, what if we make the map bigger? Let's increase the map size from 100 by 100, which is 10,000 tiles, to 500 by 500, which is 250,000 tiles. Here we go.